Good morning, welcome. My name is Craig and I'm trying to reduce suffering in product development. Last year, just to briefly recap, I shared some advances in AI related to routine tasks like GPT-3 from OpenAI. And one of the key conclusions is that learning machines are finally getting to the point where the routine tasks of a knowledge worker can start to get automated. And an update on this, which is why I wanted to spend a moment on this before moving on, is that routine expertise, the automation of routine expertise, is perhaps going to include the writing of code for simple functions. So if you don't know about this, GitHub Copilot is in the process of being created. OpenAI, they created GPT-3 by training it on all of the web, the entire corpus of the web. And then what they've done more recently is that they've trained their GPT-3 architecture on the entire body of code in GitHub, so that the vision is that a programmer will just be able to enter the name of a function, perhaps a comment with just a few words in it, and Copilot or OpenAI Codex will then fill in the entire body of the method. They're also now working on the automatic generation of the associated unit tests. And in my 40-plus year career, if this plays out, I think this is going to be one of the most significant advances in the tools that we use for software development. It seems to me the journey of a developer has been a journey of moving to increasing levels of abstraction. I started work as an assembler programmer on IBM mainframes. And so moving from that level of abstraction to now working symbiotically with learning machines in order to generate code, I think is going to be a fascinating future. And it increasingly calls for recognizing that there's this range of novelty of knowledge work, from routine expertise, which will be increasingly automated, all the way up to kind of more novel synthesis, learning, and adapting kind of knowledge. And I'd like to suggest that that will be increasingly where the value-added work is for us people in development. Okay, this year, proof it works. There's 3 sections: less clear causation, learning to see, and more clear causation. Many years ago, around 20 years ago, I wrote this chapter in one of my books. And I wasn't trying to make the case of proof. What I was trying to make the case is that there were people at the time who seemed to deny the fact that people had been using iterative and incremental ways of developing for a long time. And I wanted to lay out the message that traditional sequential development by no means was the only model. At the same time, I recognize now in retrospect, one of my real weaknesses and failings in the writing of this chapter is not really having a good sense of statistical significance, the design of skillful experiments, and so forth. So it was a work in progress. Moving on. I've gotten the question for decades, hey Craig, how do you know it works? Let's adopt Scrum. Well, how do you know it works, says the senior manager. Or let's adopt less. How do you know it works? And I've had that question, you probably have as well. So I'd like to start with a story. Quick and dirty operating system, QDOS, fact, was created with an incremental approach. Therefore, Microsoft and MS-DOS succeeded because of incremental approach. So notice that what we're doing there is we're making a causal connection. And this happens all the time. So as a very brief story on the history of MS-DOS, not everyone knows this, IBM decided to do the PC, and the IBM guy had arranged with Bill Gates to have embedded in a ROM chip the BASIC interpreter that was the cornerstone product of Microsoft. Bill Gates and Microsoft at the time were the creators of language tools, primarily BASIC. And everybody at the time used CP/M as their operating system for microcomputers. And Bill Gates and Microsoft, they sold a plug-in board, a Z80 board for the Apple II. And on this Z80 board would come bundled CP/M. And this was being sold by Microsoft. And so the IBM guy thought incorrectly that Microsoft was also the licensor and seller of CP/M. And so when the IBM guy went to Microsoft and to Bill to do the BASIC deal, he said, and we'd like to get CP/M from you as well. And then Bill explained that he and Gary Kildall, the creator of CP/M at Digital Research, that he and Gary had this kind of informal arrangement that Microsoft focused on languages and Gary did the operating systems. And while the IBM guy was in Seattle with Bill, Bill called up Gary in Monterey and said to Gary, I'm going to send someone down to you to meet and talk. Now, Bill couldn't say that it was an IBM guy because Bill had signed an NDA. So on the phone, all that was communicated to Gary was, someone's going to come down and meet with you tomorrow. So Gary didn't have any sense of the importance of this. And therefore, the next morning, because Gary had a business meeting to deliver some software to someone, which in those days you did by getting in your plane and flying to the person and giving them a disk. So Gary got on a plane in the morning and flew to this other town and delivered the disk, while the IBM guy goes to his offices where Gary's wife worked and was the business manager. And so the IBM guy comes in to Digital Research, meets with the wife, is kind of annoyed that Gary's not there. But remember, Gary didn't know that this was an important meeting. And the IBM guy puts in front of Gary's wife a big NDA, which basically sells away the rights to his children and everybody else. And so his wife, who was the business manager, is very reticent to fill in this NDA without feedback from Gary. So the IBM people are basically cooling their heels and waiting there impatiently for Gary to come back, and they're getting kind of annoyed. The wife is not especially cooperative with them, and so forth. And eventually, Gary comes back later in the day. They start to have some discussions, but nothing gets really resolved. And so the IBM guy leaves, and is a little bit annoyed. And then Bill, the next day, finds out that this has happened. Now, just a couple of months previously, Paul Allen, Bill's partner, had been contacted by the founder of the Seattle Computer Products Company. And this guy had created QDOS. And this guy, who was kind of in a relationship with Paul Allen and Bill Gates, had told them about QDOS and said, if you need an operating system, let me know. So the next day, when Bill hears that that IBM has been put off by Gary, Bill contacts the creator of QDOS, quickly arranges a licensing agreement to get the rights to the software, calls up the IBM guy and says, hey, guess what? We have an operating system too. and then the rest is history. So if one thinks about it, although no doubt that Bill Gates and Microsoft were talented, ambitious people, but if one thinks that this was a strategy or carefully planned, of course it wasn't like that. And there were a series of kind of accidents and luck that had to come together for this to actually happen. And it could have gone a very different way. So this is an exploration really of causal relationships and how uncertain those can be. Let's do an exercise. This will be a table exercise. First of all, please read this. And I'll come back to this slide, but here's what the exercise is going to be. What are all the ways this could create a distorted conclusion about causation? What are all the ways that you think of that in this apparent paper that's been published by this researcher for this conclusion that drinking soft drinks causes obesity, what are all the ways that the causal connection could actually be distorted? Please take a look at this and have a discussion with your team and write down on some Post-it notes the different ways that the conclusion could be distorted. Ding! Let's move on. We'll revisit this later. So what I'd like to explore with you today is causal inference and the causation fallacy. And if the phrase the causation fallacy is new to you, in fact, Bus and I, in the systems thinking chapter of the first Less book, we covered it in the systems thinking chapter. And the causation fallacy, in short, says every effect has one cause, and we can know what that is. And there's at least two fallacies there. I like to say everything has at least 5 inputs, so it's quite unlikely that we can find a single cause. And the fact that you can even trace to what the causes are is often a fallacy. So how do we know if it worked? Adopting less or adopting Scrum or whatever. And I've heard this question so many times over the decades, and I bet some of you have heard this question as well. And I hear this question from senior management and others with respect to change ideas. But you know what? I've never heard this question, how will it work? How do we know if the business case or the project or the feature or the management practice was proven to cause the benefit? I've never heard those questions. You know, I go to a company where they've been doing management by objectives for the last 50 years. And none of the managers have ever actually asked, is there any evidence that this is actually useful? Does it have a causal influence on the things that we care about? You never hear these kinds of questions. And so, in part, what I'm trying to explore with you is the most frequent fallacy in business, which is correlation versus causation. Please read this. So if you like cheese, you should be very afraid when you go to sleep at night. And these authors decided to do a fun experiment. They took a cookbook and they randomly opened it to a set of recipes. And then from the ingredients from those set of recipes, they extracted 50 of the common ingredients in those recipes. And then they did a literature search, and they were able to find for every one of those recipes all kinds of studies that showed that that ingredient caused cancer. Every one. Well, during the COVID lockdown, when I had a lot of free time, I started to do a lot of reading in depth in the following journals. I read a lot of Journal of American Medical Association, New England Journal of Medicine, and others. I started to become interested primarily through the medical pathway into the design of experiments, causality, causal inference, and so forth. And I really became interested in what was the state of the art of how researchers and scientists practice in this area. Started to look at more books on causal inference and statistics and so forth. And one of the things that I learned, and this is really worthwhile knowing, is that there is a modern gold standard for causal inference, and it's called a randomized controlled trial. And in a randomized controlled trial, which I'm sure many of you know, but perhaps not all, you start off with a statistically significant population, and then you randomize the people or the objects of the treatment into different groups, into a treatment group and into a non-treatment group, so that there's no biases about who's selected to get the treatment. And this is one of the most powerful gold standard design of experiment tools these days to really try to tease out causal influence. That's one of the things that I learned. This is an example of what you would find in a typical JAMA research paper. Please just take a kind of a quick scan over that. The fine details don't really matter. The bottom line, without getting lost in the details, is when I started to see research and experiments run like this, and then I would look at a book on management studies or business research or psychology research, it just looked grotesquely inadequate in comparison to the bar that serious scientists were trying to set for really trying to understand the causal influences on things in comparison. And so then I started to see that a lot of business and management studies and conclusions look like crap in comparison, including all the ones published at all of the universities around the world, from Harvard Business School to Stanford Business School to Sloan School of Management and MIT. When you compare what they're publishing to this stuff, it looks like absolute crap in terms of the conclusions that business and management experts are talking about. There is a body of researchers which are basically statisticians who specialize in the design of experiments, and they've got a pretty good idea of how to work on this. And when these people, when they look at all of these different approaches to experiments and statistical analysis, one of the things that they observe is that any claim coming from observational studies is most likely to be wrong. That's in contrast to randomized controlled trials. And virtually every management study and business study is just an observational study. To take it even further, so they found 52 published studies that were observational based in which the scientific researchers at universities claimed that there was a meaningful influence and cause. Every one of those failed when it was put to the serious test of a randomized controlled trial. This is now the most widely cited paper in all of academia, if you didn't know. Around the world, this is the #1 most cited paper, why most published research findings are false. And this is not only true in the hard sciences, but doubly true in social sciences. It's so easy, I've come to learn, to be fooled by randomness, to be fooled by confounding variables, so we don't really understand what the true causes are, and to be fooled by a basket of biases. Therefore, I'd like to suggest to you as a heuristic, if you see some web article or you hear some news, or even if you read the published article in a journal, and if that journal is related to business, sociology, psychology, nutrition, exercise, epidemiology, it's just crap. Digging into statistics a little bit, who's familiar with statistics and things like P05 and so forth? Okay. In statistics, one of the tests that you apply is to try to understand whether what you're observing is just due to randomness or whether there's some meaningful statistical signal. And the P05 measure, which is typically used in the social sciences and business studies, basically is saying that 5 times, and this is not exactly accurate, but it's, I think, a simple approximation, that on average, 5 times out of 100, these results could be explained by just randomness rather than by a strong causal relationship. Now, it turns out, first of all, that's just on average 5 times out of 100. Sometimes it could be 20 times out of 100 or 30 times out of 100. That's just an average. And it turns out that 5 times out of 100 happens all the time in the universe. All the time. It's so easy. And the social sciences, they typically have this very low bar on publishing, I've come to realize, because if they were to set the bar higher, like they do now in physics and genetics and chemistry and so forth, no researchers at universities could publish anything, because if they actually set the bar to a meaningfully high standard, they couldn't show any results. That's one important point. And because a lot of these university departments in sociology, psychology, and so forth, they don't get a lot of money, and the professors in these departments are struggling to get something published, they have to set the bar really low in order to get anything published. And the journals that are receiving this, they're receiving essentially crap and publishing this as well, because the whole field is a very low bar field. Therefore, and this is, if you will, kind of a key point of this talk, I'd like to encourage you, if you ever hear any claim from any industry report about anything, it's just fucking bullshit. It's just nonsense. I did a kind of a deep dive into the management published research lately, and I was able to find one rare exception in business, and I wanted to really promote and support these researchers. This is the only meaningful randomized controlled trial that I could find published in the field of management. Isn't that interesting? I'm sure there are a few more, but this is the only one I could find. And interestingly, for our interests, it was an experiment that showed that if you teach entrepreneurs to take a scientific method approach to development, which is something that I've been promoting for a very long time, to have the humility to say it's just a hypothesis, it might be wrong, to try to falsify it, to get data, to falsify your hypothesis, and then to pivot, that the startup companies that were taught that and applied that had a different result. Now, in addition to the intrinsically difficult problem to make a causal connection to any outcome, what about the influences of measurement and incentives on the data and the reports that are published? Please read this. Some of you might be familiar with what's called the replication crisis in the social sciences, in management studies, psychology, sociology. What's been able to be shown now is that almost all of these studies and conclusions in psychology, sociology, and so forth don't replicate, which is not surprising because they had such a low bar, a p05 on statistical significance, and because they did things that are called p-hacking or data dredging. So for example, in that University of Mississippi student obesity story that I told you, let's imagine that the researcher had also originally included 50 students from the University of Helsinki. But there was no statistical significance from the students from the University of Helsinki, so he deleted all of that data. And he just cherry-picked for the data that would actually finally, that he could torture it enough to get some weak statistical signal. Therefore, publication bias refers to what I was just talking about, which is cherry-picking what you can bias and only cherry-picking what you can publish, and only publishing when something is shown to be significant. And I like this title, The Importance of Understanding Human Psychology and How Measurement and Incentives Play Out on What People Publish in Management, Business, Psychology, Sociology, and so forth. Please read this. So the point I'm making is that even in universities, scientists with PhDs in a culture and an environment where ostensibly the value is quality data, honest conclusions, we now know that there's a world of bullshit and gaming and distortion of the information. Well, if you don't think that doesn't happen in the business world, with the forces there, which is why, if you've read Measuring and Managing Performance in Organizations by Dr. Austin, who's at Harvard Business School, he explores in this book that measurement dysfunction, the dysfunctions that arise from introducing measurements, is endemic, it's everywhere. And a key point that he identifies is that measuring itself, the act of measuring, drives this dysfunction. And that doubly so that these dysfunctions, of course, are made worse by incentives, and that you aren't actually measuring what you think you're measuring, and that people who promote measurement are naive about human psychology. Because of measurement dysfunction in business, reports, status, KPIs increase inaccurate data and degrade transparency. That's why I'm always amused. Sometimes people tell me, oh, we've got this new agile management tool that we've installed, Raleigh version 1 or whatever, and they say to me, and It's got lots of reports, so we've increased transparency to the senior management. No! It's the exact opposite. Reports don't increase transparency, they reduce transparency. The story of moving to remote workers in software development and its impact on the delivery of value. I've worked at a company where during the times of COVID, all of the software development staff went remote. And the senior managers of the company were then told, after they all went remote, they were told by the middle managers who did the measuring, this has had no impact on our delivery of value. And therefore, in the future, we're going to get rid of a bunch of our offices and we're going to just move to a major remote worker model. And the senior the C-level are going, great, that sounds wonderful. And no one actually bothered to dig into what was going on. So when I was there, I was curious about this result, so I decided to dig into actually what was going on. And I discovered the following. This company defines delivering value as whatever a person produces. So for example, they have business analysts that produce documents. Every time they produce a document, that's value. They have UX designers who create wireframe documents. Every time they deliver that, that's value. They have component teams who write code, and any line of code that they produce is per definition value. The entire company's definition of value is exactly equal to outputting of the single task outputs of individuals. That's literally their definition. The C-level, by the way, didn't even know this because the middle management are playing these bullshit games in order to manipulate the senior management. And so, of course, when everybody went remote and they measured the impact on value, it had absolutely had no influence at all. And so the conclusions of the C-level is, great, remote work has no impact on delivering value. It makes me sad and amused at the same time. I like this quote by Sidney Dekker, "What gets measured gets manipulated." You might have heard of this old quote by, I think it's Drucker, who said, what gets measured gets managed. That's the kind of a statement from a person who spends their whole life just teaching management classes like Drucker did, but never actually being in a company and actually working on a product and seeing the consequences of what happens. It's not that what gets measured gets managed. What gets measured gets manipulated. Moving on. Many years ago, I used to go to companies and I would say something like, wow, if we create strong feedback loops with transparency about the result of your business ideas, then this is going to be really great and you're going to love this. Let's introduce strong feedback loops and transparency so that we can see the results of your ideas. I used to actually believe that the business people would like this idea. It took me a long time to discover this. That's what's really going on in people's minds. Because. And so there's not only a replication crisis in the social sciences, there's a replication crisis in business cases. When I go to work at a company, if I'm there for a while, I'll usually ask the senior management, how frequently do you look at all of your completed business cases and look at the results of whether the 5-year projections actually happened? I've never once had a company tell me that they actually did that. So it's just based upon wishful thinking. Same thing with projects and initiatives and software features and change. So back to the exercise. What are all the ways this could be distorted in terms of understanding causation? Here's some of the forces. And more. So how do we know if it worked? How can we have proof it worked? It turns out, therefore, that we can't. For many of the things that we care about, we can't. And that's a key conclusion that I want to make. If for the rest of your life, if you're trying to introduce some new method, organizational design idea, process, you will never be able to prove it worked if you start to appreciate, from the point of view of science, the appropriate design of experiments, how difficult it is to identify causation, and all of the things that can influence results. But the good news is that there are some things that we can create a bright line from effect back to cause. And in the last two short sections, I want to touch on those. The first of these I call learning to see. So if we want to understand what's going on, what some of the effects are, the first thing that I'd like to talk about, and Bus and I touched upon this in our third less book, is the influence of whether the measurement is imposed or it comes from ourselves. I often summarize it this way. Go to your significant other and say to them, my goal for you is that you're going to lose weight. Watch how that goes. And yet, that's what managers do all the time in organizations. Human psychology, understanding how people actually behave. In contrast to, I want to lose weight. I'm going to measure this body because I have this intrinsic motivation to do the measurement for myself. It's night and day in terms of the dynamics of what happens. And then also the distortion of the measurement result. Because I'm not so much interested in fooling myself. Well, maybe I am with respect to weight. Another way to see better and to reduce distortion is to actually go see the running product at the sprint review. I know I'm preaching to the choir here, but it's so important, I think, to reinforce the point that if you want to see what's going on, go and see what's going on. A JIRA report is an illusion. And go see it Gemba. And I know this is a tough one because the heart of Gemba in software development is actually in the code, the people working in the code. And Bus talked, was it 2-3 years ago? You were talking about how people who don't really understand code can learn a little bit more. I think you gave a keynote on that subject. Oh, yesterday too. Because I know you did it some years ago at the LESS conference. Yeah, I wasn't here yesterday. That makes it harder when you're not really familiar with the code, of course. And then finally, what are some ways that we can actually have more clear causation? A small set. Because fortunately, there are some cause-effect relationships that can be identified that don't require empirical studies. And what are some of those? It seems to me that these are three ways. And by the way, we're going to have a short discussion at the table in a moment for possible other ways, because there could be ways that I haven't thought about. The first is quantitative reasoning. I'll give an example. The second is queuing theory analysis. I'll give an example. And the third is systems modeling that identifies, let me call it, very strong influences. For example, quantitative reasoning. I'm not going to go through the details of this in this talk because many of you have seen this before. But if you explore quantitatively the question, how many lists do we have? How many prioritizers of the lists do we have? You can do solid quantitative economic reasoning about the relationship between the number of lists and opportunity cost and the probability that you're working on highest value. And this quantitative reasoning is a very strong and clear line of both logic and influence. There's nothing fuzzy or probabilistic about it. So there's sometimes we can draw conclusions that way. Second, queuing theory. Please read this. This is just a fact about how queues work. Who knows about the beer game that's sometimes taught in MBA programs? One of the things that's come to me in the last year is that if you're working with a group of people and they've done an MBA and they were taught the beer game, many of them have learned through the beer game the influence of delay, queues, on creating longer cycle times. And so there's a lot of management folks who understand that idea through their MBA education. But unfortunately, they've not often made the connection of that beer game model, which is a physical supply chain. Many of them don't appreciate that that model applies to digital supply chains as well, where knowledge workers are creating digital artifacts. And if you can make the connection for them to that this applies to your workers in software development as well, then they can start to see how the dynamics of queues and delay also play out in software development. And then in systems modeling, there are some influential relationships which I call per definition or definitional. So for example, the number of products influencing the number of lists in terms of the number of products. It's per definition that in Scrum, every product has a product backlog. And so we don't need empirical research or statistical studies to understand that causal relationship. And then there are some relationships that are not per definition, but are strongly probabilistic, such as the relationship between the code quality and the effort to modify the code. Most people, even if they're not programmers, understand that that is surely going to be a very strong and influential relationship. And so it seems to me that these are three baby step ways that people can actually start to find connections between cause and effect. Now, before we close down on this section, I'd like to invite another short exercise, which is I'd like to invite you to have a discussion and maybe a bit of sharing afterwards. Are there any other ways that we can find sources of clear causal influence when we're working with people? Please have a short discussion with your table. Ding! So, because I'm interested in understanding if the list is longer, I'd like to invite just from the audience if anyone else has identified other ways of getting sources of clear causal inference. Did anybody have any other suggestions they'd like to share? Yes. Yeah, A/B testing. Any other suggestions? Bacon land, a good place to end. Thank you for your time.